Hi, also this chapter we will be talking about cardiovascular system, chapter 18, or the heart basically. So we'll first talk about the size, shape, location, and orientation of the heart in the thorax or in the thoracic cavity, the layers of the heart wall, the chambers, and then the heart valves. So firstly, heart is associated with two circuits, the pulmonary and the systemic circuit. And what do I mean by that? It means that the right side of the heart receives the oxygen poor blood. Okay, the right side receives oxygen poor blood coming back from the tissues, like after metabolism. So they're high in carbon dioxide, oxygen poor, and they are getting received into the right side, and from there it goes into the pulmonary circuit. Okay, why pulmonary circuit? Because pulmonary circuit is directly connected to lungs, so lungs will give the required oxygen. And then the other side is the left side that receives the oxygenated blood back from the lungs. All right, and when it receives back into the heart, from there it goes into our body systems with the systemic circuits. Okay, so two circuit, pulmonary and systemic circuit. Pulmonary circuit attached to lungs, systemic circuit attached to body systems. And the pulmonary circuit is actually connected to the right side, and that receives deoxygenated blood. The left side connected to systemic circuit, where it receives the oxygenated blood from the lungs and sends it to the body systems. Now heart, approximately the size is, it varies from person to person. It is approximately for each person it is size of your own fist, so you can measure that on that way. Okay, any of it, like, it will be all different from each person. Like your fist size will vary, the heart size will also vary. The weight is less than a pound typically. Location is in the mediastinum, between the second and fifth intercostal space, and on the top of the diaphragm. So the heart is on the superior surface, the superior edge of the diaphragm. 2/3 of the heart is towards the left side or mediasternal side, so kind of it is a little bit inclined towards the left. It's anterior to the vertebral column, so this is the vertebral column, anterior to the vertebral column, but behind or posterior to the sternum, so in kind of in between that. Heart has two surfaces. One is apex, which is the bottom, this point, and this whole wide area, this is called as the base of the heart. So apex is at the bottom. Okay, the apex is towards the left hip, so this is the left side, and the base on the other hand is leaned towards the right shoulder, so it goes in this direction like that. Okay, so that's the right shoulder, that's the left hip. Apical impulse is palpated between the fifth and sixth rib, which is just below your left nipple. Now, in terms of chambers, there are 4 chambers of heart. First of all, right atrium, left atrium, right ventricle, and left ventricle. Okay, 1, 2, 3, 4. Now, the 2 atrium, right and left atrium, these are the 2 receiving chambers of heart. Okay, the right atrium receives blood, the deoxygenated blood again. It receives from the systemic circuit, it's coming back from all the systems. And the left atrium receives blood, the oxygenated blood actually, it comes back from the lungs, which means it is getting the blood from the pulmonary circuit. And the 2 pumping chambers, which pumps blood actually, is the right and left ventricle. So right ventricle pumps blood to the pulmonary circuit, left ventricle to the systemic circuit. So we will talk about all these circuits and circulation later, but just remember for now, the receiving chambers are right and left atrium. Right atrium receives deoxygenated blood, left atrium received oxygenated blood, and the pumping chambers are right and left ventricles. In terms of the coverings of heart, the covering of heart is called as pericardium. Okay, this is a double-walled sac surrounds the heart, made up of 2 layers. The most outer layer of pericardium is called as the fibrous pericardium. Okay, this actually functions to protect, anchors the heart, and prevents overfilling. It's on the outer side. Inside that is the parietal. Inside that is actually the serous pericardium, And among serous pericardium, the one that is directly connected to the fibrous pericardium is called the parietal layer. Okay, so fibrous pericardium and parietal layer of the serous pericardium kind of attached together. In between, we have a cavity called pericardial cavity. Below that is the visceral layer of the serous pericardium, which is this one, this layer. Now, another reason why it is called visceral layer, because it is directly attached to the visceral organ. Visceral organs mean essential organ, and of course, heart is a visceral organ, right? So that is directly connected to heart. Now, this cavity, this is called as a pericardial cavity. It's not empty; it is filled up with a fluid. Okay, and the reason it is filled up with a fluid, because that fluid actually reduces friction while the heart is moving. Because we are always, although like heart is always on movement, right? Even though we are sleeping, heart is still moving, it's beating all the time, so it has to be have the least amount of friction during that movement. On the other hand, this visceral layer of pericardium, what we just discussed, this is also called as epicardium. Okay, so below epicardium, that's the external layer. Below epicardium, we have got the contractile cardiac muscle cells, which is also called as a myocardium. And then the innermost layer, which is directly lining the heart chambers, that is called as the endocardium, right? So these are the heart walls. In terms of chambers, we discussed there are 4 chambers: right and left atrium and right and left ventricles. Now the atrium is actually separated by a separation called interarterial septum. So suppose this is right atrium, this is left atrium, here will be the interarterial septum. Okay, there is also a feature on this which is an indentation kind of, which is called as the fossa ovalis, which is remnant of foramen ovale of fetal heart. So foramen ovale exists only in fetus, not in an adult. In adult, it becomes fossa ovalis, a small fossa type of thing. What it is, it will talk about at the very end of the chapter. Just remember the feature that there is fossa ovalis in an adult heart. And then also we have right ventricle and we have left ventricle, and that similar to the atrium, this is also separated by the interventricular septum. Okay, so interventricular septum, but this is much more thick. And then also we have coronary sulcus, okay, which is encircles the junction between the atria and ventricle. So we'll talk about that in a minute. What is that? Now atrium is the receiving chambers, both the atria. Now what kind of blood it receives, that depends on the side. For example, the right atrium receives the deoxygen, all the right side of the heart receives the deoxygenated blood, and right atrium is actually the deoxygenated blood receiving chamber, right? Both the atrium has a small flap or small extension to it. These are called as auricles, for example, which is like gives a little bit of extra volume to this atrium. So for example, auricle of the left atrium, and there is also auricle of the right atrium. But inside that is the atrium, and this right atrium actually receives deoxygenated blood. Now who supplies this deoxygenated blood? It is supplied by 2 big veins called superior vena cava, this one, and then inferior vena cava, which is at the bottom, this one. So here and here. Okay, they actually are draining from superior part of the body or inferior part of the body. So any organ that is above the diaphragm, all deoxygenated blood drains into the superior vena cava, and superior vena cava now opens into right atrium. Similar to that, all the organs that is below the diaphragm, they open up into the inferior vena cava. All the deoxygenated blood goes into from the bottom part of the body or below the diaphragm, goes into the inferior vena cava, and that again opens into the right atrium. So both of these actually open here. There's another one is called coronary sinus. What is that? Which is here, this coronary sinus, this here. Okay, sorry. So what is that? This actually returns blood from the coronary veins. What is coronary veins? All the veins that are attached to the heart. So in general, veins carry deoxygenated blood. So coronary veins typically will carry deoxygenated blood from the heart itself. So remember this, veins carry deoxygenated blood. Okay, veins carry oxygen poor blood. Similarly, all the coronary veins, which is the veins of the heart, they carry deoxygenated blood from the heart, and heart is also an organ that uses blood, and then that drains into coronary sinus, that also opens into the right atrium, right? Similarly, the left atrium, as opposed to the right atrium, receives oxygenated blood. It does not come from the organs, obviously. It comes from fresh from lungs, because we have breathed in that oxygen through lungs, and then that oxygenated blood goes directly into the left atrium, okay, from here. And who supplies it? There is no vena cava here, but here the pulmonary veins, this a pair of left pulmonary vein and right pulmonary vein. So this left pulmonary vein is actually also connected like that. It is also connected to the left atrium. So all of them open up with oxygenated blood into the left atrium. Now remember this color code. Anything that is oxygenated will be colored in red, okay? Anything that is anything that is colored in red, that means that is oxygen rich, okay? Oxygen is high in there. And anything that is colored in, that's true in our body also, in blue, that means that is oxygen deoxygenated or low on oxygen, okay? Now these are the two receiving chambers, one receiving deoxygenated, one receiving oxygenated blood. The other one is the other two chambers are the discharging chambers, so which is left and right ventricle, right? So the right ventricle, this one on the anterior surface, and the left ventricle is here, the posterior anterior surface. There are trabeculae carneae, which is the irregular ridges. There's some ridges actually in the ventricular walls. It's called as trabeculae carneae. There are some papillary muscles which are in the chambers of ventriculi. These are attached to the chordae tendineae. Okay, these are connective tissues. We will talk about that. So papillary muscles and chordae tendineae, these are two attachment that keeps the valves closed. Okay, but they are in between. They are basically sitting on top of the ventricles. But these two are actually related to the heart valves, which we will discuss in next couple of slides. So, but these are the features. They sit on top of the ventricles. Now, the ventricle itself, like you can see, they have got thicker walls because they need more force to eject the blood. Okay. Now the right ventricle, this one, opens up into the pulmonary trunk, which is this one, through the pulmonary trunk, okay, or the pulmonary artery. Now remember, all arteries, like we discussed, all veins carry oxygen poor blood. But remember we said that in the left atrium, these pulmonary veins actually drain into the left atrium. This is the only exception when a vein is carrying oxygenated blood, okay? Otherwise veins will always carry deoxygenated blood. Similarly, here we have got another exception. Like arteries always carry oxygenated blood, but this is the only exception. This is the pulmonary trunk or the pulmonary artery that is carrying deoxygenated blood from the right atrium. So this atrium, from the right ventricle. The right ventricle actually pumps the blood into the pulmonary trunk or the pulmonary artery. Okay, and this is the only artery that will carry deoxygenated blood. So that's right ventricle. Now what about the left ventricle? Left ventricle is the left side, so it is carrying oxygenated blood, but this will drain into aorta. Aorta does not carry any deoxygenated blood. It carries oxygenated blood totally, and this is the largest artery of our body also. So this left ventricle directly drains into aorta, oxygenated, but the right ventricle drains into the pulmonary trunk, okay, which also divides, which is nothing but the pulmonary artery. So two exceptions is pulmonary artery and pulmonary veins. Pulmonary veins carry oxygen rich blood, which is an exception because veins carry oxygen poor blood. And pulmonary artery actually left or right in thing, they will carry oxygen poor blood, which is also an exception because artery always carry oxygen rich blood. All right. In terms of the heart valves, valves are actually present between among different chambers of heart. Okay, and why are they present? Because they ensure unidirectional blood flow. So once the blood flow had happened, this valve will close so that it doesn't flow back in the chamber again. There are two kinds of valves: atrioventricular valves and the semilunar valves. Atrioventricular means they are between the atrium and the ventricle, atria and ventricle, and semilunar valves are between the ventricle and then some arteries. Okay, and there are no valves between major veins and arteries. This is not a problem because there's always inertia happening that is keeping that prevents the backflow. Okay, now what are the valves? Four valves: pulmonary valve, aortic valve, mitral valve, and tricuspid valve. Okay, let's see what are these. So tricuspid and mitral valve or bicuspid valve, same thing. So tricuspid valve is the right AV valve, which means it is between the right and left, right atrium and the right ventricle. Okay, right AV valve, right atrium, right ventricle, between that. Okay, and they have three cusps, mean it looks like three leaflet like this. Mitral valve or bicuspid valve, it has two leaflets like that in between the left atrium and left ventricle. Left atrium, left ventricle. So that's why these are called as the AV valve. Here we see this chordae tendineae, these connective tissue. What do? They actually keep the valves closed with the help of papillary vessels. So when these, suppose this is the valve itself, the valve close means the chordae tendineae, which is, these are like anchored to the valve wall, and then it is anchored to the papillary muscle. When the valve is closed, it's like this is the valve, and when this valve has to open, then it will simply open like this. Right, so the valve is now open, and then the chordae tendineae will pull down itself, and here are our papillary muscles. Okay, so basically the job of chordae tendineae, so this is a closed position of the valve, this is an open position, so it is basically pulling the cavity up, or basically opening the cavity, opening the valve up. Okay, or that's why it says it holds the valve flaps in closed position. Okay, now the two semilunar valves are pulmonary semilunar and aortic semilunar valve. The aortic semilunar, as the name is saying, it is at the base of the big aorta, this huge aorta. So therefore, where it is located? It is located between the left ventricle and the aorta itself. Okay, the pulmonary semilunar valve, it is between the right ventricle over here and then the pulmonary artery or the pulmonary trunk. So remember these two. One is at the base of the pulmonary trunk. Both are semilunar valves, so that's why it is called as pulmonary semilunar valve. And aortic valve is at the base of the aorta. That's why it is called as the aortic semilunar valve. Four valves. Quick exercise for you. You just have to identify these structures. For example, what is A? A is the right auricle. B is the left auricle, right? C and D, pretty easy. Right ventricle, left ventricle. D is the left ventricle, C is the right ventricle. These are the chambers. What is E? E is something that is draining into here. I'm sorry, not that much. This is something that is draining into this chamber, which is the right auricle or the right atrium. So then this is the big vein, or the big vein that we spoke about, that drains from the top part of our body, which is nothing but this huge vein, or here, this huge vein. So therefore, that is the superior vena cava, okay, opening into the right atrium. Alright, F is this one, which is opening at the base of the right, or opening at the right ventricle. So therefore F is the pulmonary artery or the pulmonary trunk. G is basically this guy, so behind the pulmonary trunk, this huge thing. What is this called? This is the big aorta, and when this aorta is forming an arch, we call it as the aortic arch. It actually bends like this and goes into the bottom like that, travels to the bottom. G, and then the last one is H, which are these fiber-like stuff, which are the chordae tendineae, which opens the valve, keep the valves closed. All right, so these are the different structures. What is the double-walled sac covering the heart called as? We did discuss that, the heart covering, when we spoke about the heart wall. So double-walled covering of the wall, you can figure out from this slide. Then the valves. What are the valves? So there are 4 valves. So let's talk about B and D. B is between the right atrium and right ventricle. So B is basically the tricuspid valve. This is between the left atrium and this is the left ventricle. So therefore this is the bicuspid valve or the mitral valve. This is the aorta. The valve at the base of the aorta is called as the aortic valve. Therefore this has to be the pulmonary semilunar valve, because this is the, in front of the aorta is the pulmonary trunk or the pulmonary aorta. So this is the pulmonary valve, semilunar valve. Now there could be some chronic conditions related to valve. What is that? If you have incompetent valve, it means blood back flows into heart and repumps the same blood over and over, or valvular stenosis means stiff valve that constricts the opening. We can actually replace valves with mechanical valves or cadaver valves or even animal valves. In terms of the blood flow, so this is the last thing we're going to cover in this section of the lecture, and we're going to repeat this over and over. So quickly we'll go over this. So SVC and IVC means superior vena cava and inferior vena cava. So these are the 2 huge veins. So we learned about that the veins actually capture deoxygenated blood from our body. All that blood drains either into superior vena cava or into inferior vena cava. Superior vena cava is connecting to all the organs that is on top of the diaphragm, and inferior vena cava connects to all the organs that is below the diaphragm. Both of these open into right atrium. Okay, you can follow this circle while I'm talking about. So from vena cava it goes into the right atrium. Okay, from right atrium it will go to the right ventricle, but it will travel through this valve, tricuspid AV valve. Okay, now from right ventricle, now this is deoxygenated blood, it has to go to lungs. So from here it will pass to the pulmonary semilunar valve and it will go into the pulmonary artery, and from here it will go to lungs. Okay, now it's oxygenated in lungs, now it is coming back. It will connect into pulmonary veins, PVEs. These are the pulmonary veins. Okay, there are 4 of them, right and left, and both will open into left atrium. Okay, left atrium will pass it into the left ventricle, but through the bicuspid AV valve, the mitral valve. From the left ventricle it will go into the aorta, because now it is the oxygenated blood and aorta will pump it into the rest of our body. But before that it has to pass through the aortic semilunar valve. Through the valve closes, and then the aorta will push it into the body. So once the blood is pushed through the valve will close immediately, so that there is no backflow. For example, if the blood is flowing from right atrium to right ventricle, immediately the blood is here, this tricuspid valve will close, so that there is no backflow. Same for all the valves. Again, the only exception, the only vein that carries oxygenated blood is the pulmonary vein, right or left. The only artery that carries deoxygenated blood is the pulmonary artery or the pulmonary trunk. All right, so blue is the deoxygenated blood, right is the oxygenated blood. Right side flows the oxygen poor deoxygenated blood, and the right side actually flows the deoxygenated or the oxygen poor blood. The left side drains the oxygenated blood or the oxygen rich blood. All right, so as a homework you will actually go through all these slides, learn through all of these blood flow, and then listen to this video, and then take all your notes, go to textbook, practice it over and over, and then write down the pathway of blood flow in heart. This is a must do practice activity that you should do multiple times. Like, write this from 1 2 3 4 5 6 7 8. Keep a drawing handy at first, and then you can create your own drawing. For example, you can draw like this: right atrium, right ventricle, this is connecting to SVC, is carrying to IVC, like that. So means this is deoxygenated blood is going to atrium. From here this will go to the right ventricle, and from there it will go into the pulmonary artery, like that. So you can create your own diagram like that as you are studying, and keep practicing this over and over. In the next segment also we will start from the pathway of heart to blood. All right, okay, see you then.